Welcome back to the classroom. My name is Mr. Wong. We're going to explain the exam today using the 2017 Victorian Physics paper, question 8. So it says we have a roller coaster that is arranged so that the normal reaction force on a rider in the car at the top is briefly zero. So there is no normal force in essence. The section of the track at point P has a radius of 6.4 meters. Calculate the speed that the car needs to have to achieve a zero normal force on the rider at point P. So the idea is, so as the rider goes up on this roller coaster, there is no normal force at one particular point, let's say at the peak height. As you can see, the person is falling down. So what's actually happening is there is the gravitational force only pulling our rider down. So our gravitational force in this example here would be the only force acting on our roller coaster rider. So it will be the origin of our centripetal force, which means I can actually write the following equation. I can say that mg, or actually we'll go a little bit further. Fg is equal to centripetal force. That gives us mg equals to mv squared over r. I can then rearrange the formula to look like this. G equals to v squared over r, because I've essentially cancelled out my masses because they would divide each other. I want to find velocity, so it would become v equals to the square root of rg. Okay, so r in this case is 6.4 meters. Acceleration due to gravity is 9.8. And so the value we get, if we put that into our calculator, is approximately 7.92. But let's just look at what the sig figs show us. The sig figs, lowest sig fig of this question is actually 2. So we're going to round it off to that as well. So 7.9 meters per second. That's the speed in which the roller coaster rider needs to reach in order to have a temporary zero normal force at that point. Okay, next question. The car is faulty and only achieves a speed of 4 meters, so we're about half the speed at the top of the arc at point P. Calculate how fast this car would be moving when it reaches the bottom at point Q, which is 5 meters below point P. Assume that there is no friction and no driving force of the car. So our dude or lady is coming down here. There is a drop in 5 meters. Their velocity at this point is 4 meters. What do we have down there? So we're calculating what the velocity here would be. Okay, velocity 1, velocity 2. Well, what that is telling us is we're dealing with conservation of energy. Okay. So we're trying to look at what is the total energy and final energy. That would give us an idea of what's going on. All right, so we know the total energy of any system is its kinetic energy plus its gravitational potential. Okay, height 1. And that should equal to the kinetic energy and gravitational potential energy at the end of the motion. Okay, so that's our equations there. What we want to find is v squared 2, or v2, sorry. So that's the value we want. Okay, so we actually know majority of these numbers, so we can actually begin to do some substitutions. Okay, there's no mass given to us, so we need to work it out that way. Okay, so it appears that we have an issue here, that we don't have mass of the roller coaster. Now, there's probably a reason why they don't tell you here, but you can actually just give an estimated number. So we can estimate that the mass of the object is 1. Okay. 1 kilogram, and we can work our way around there. The reason why we can, or it can actually be any number really, the reason being is because the mass we're looking at is of the same object. So in a way, the ratios or the changes in mass doesn't exist. You'd still get the same mass overall. So you can consider it as 1, or you could use any other number, or you might not even want to consider the mass at all. But we'll just use 1 and go from there. So it's half times 1 v1 squared. We said it was at 4. 1 of the mass, 9.8 of gravity, and h1. So what's the initial height? Is it 6.4 or is it 5 meters? Well, we're going to actually say it's 5 meters because that's where the actual change in displacement is going for. Okay, so that's our consideration in this system here. So it's going to be 5 equals to half v2 squared. Reason why it's just v2 squared, I just made that a 1, so it doesn't really matter. And then 1, 9, and then 0. So since we have a 0 value, we're going to get 0 gravitational potential at the end of the ride as we hit down. So let's substitute this left-hand side, and we get a value of 57. Now I want to move this half over, so I'm going to times this side by 2 and also this side, so it's going to be times 2 v squared. So v2 is the square root of that value there, which is 114, which leads us to approximately, again, to 2 sig figs, about 11 meters per second at the end. If we were to do it to 3 sig figs, it would be around 10.7 meters per second. Okay, so that's how you do the question. Or actually, it might just mean that they want it in 1 decimal place. Either way, 3 sig figs here would be a much more accurate number than the 11, as you can see there. So it probably meant 1 decimal place. Anyhow, that concludes our explanation for this question with our roller coaster, this one here. If you found explanations like these useful in tackling past exam questions, hit the like button and subscribe if you haven't done so already. Thank you for listening up. I'll see you next time.